SwayamPrabha. Digital India. Educated India.
Welcome back. Module 3 will cover data collection and survey techniques, and lecture 11 is on sampling theory, part 1. So the different concepts covered in this lecture are sample design, sampling error and sampling bias, sampling procedure, probability sampling, and non-probability sampling. So, when we talk about samples, we require samples because we cannot survey the entire population. Whenever we are doing any kind of study, either be it land use or transportation or land use transport interaction, we cannot survey the entire population. We can only survey a handful of the population, and that is where samples are important. And we should design or determine the both the which persons to survey, and so and also the number of persons to survey. So the design of the samples should be such that it should represent the population efficiently, so that whenever we analyze the data of the samples, the results could be also we said that the results also represent the population as well. So because we don't have enough time or money to survey the entire population, that is why we have to only stick to a particular portion of the population, which is our samples. Now, the sample design should consider the characteristics of the population. There are certain population which are finite. That means there is a finite number of people in an urban area. But we can also, there are certain populations which are infinite. For example, amount of, if we are surveying, we are collecting water samples, then the water is infinite because there is no end. We cannot estimate that, okay, there is so much amount of water in particular area. So, it depends on what we are actually surveying. And then there is, we need to also understand the sampling unit. For example, the geographical location, the socioeconomic group of people for whom we are interested, ethnicity or religion, or it could be for an individual or household level. So depending on what is the unit of survey, we determine the appropriate sampling unit, or what we are surveying, what is our final goal. Based on that, we determine a sampling unit. Then we should have a source list, which means basically we need to have a list of all the elements of any finite population. That means if it's an human beings in an urban area, we need to have maybe the list of all people, either using any kind of identity card or any kind of other information. So we require the full list of this group that we are surveying, or this population that we are surveying. And this is particularly required for probability sampling, because in that case, if only we have the list of all the names, then we can randomly select some of those names or some of those people. But if it's we don't have those lists, then we cannot go for probability sampling. We have to go for non-probability based sampling techniques. And it is, of course, the techniques vary as per the context. Then we also look into the different parameters of interest. For example, what is the key, and this helps us in determining the sampling unit, size, and procedure that we will adopt. Means what should be the method of surveying, what should be the size of sample size. All this is also determined by what we are interested in. Are we interested in the age of the population, or we are interested in their educational profiles, or what parameters? So that actually determines the sampling procedure, sampling size. For example, if I am trying to survey bicyclists in an urban area, then of course the parameter of interest is a person having a bicycle. So that we cannot find that we cannot immediately say that all persons are going to have a bicycle. Only a few persons will have a bicycle. So we have to determine only people having bicycles as our sampling unit. So this is how we have to also be careful about which parameters we are studying. Then sampling procedure, this is the technique of survey. This we will cover in this particular lecture in detail. And then there is also size of the sample. How we should determine sample size. This will be taken up in the next lecture. And usually the size of the sample is depends on the desired level of precision or sampling error, we call it. We will explain that in detail and later on. And then the acceptable confidence level. And that is basically what confidence we can say that the error will be what we are saying is the matches with the desired level of precision. Then parameters of the population means what exactly characteristics of the population that we are studying, the size of the population, the total size of the population, and the size of the population variance means what is the standard deviation or what is the variability of the different observations that we take. So when we talk about sampling, we have to consider that the sample design is accurate as well as precise. That is where we need to talk about sampling error and sampling bias. Now, sampling error is an error associated because we are only studying a particular few individuals instead of the entire populations. Because if we have studied the entire population, like for example, age of the entire population, we could have got everybody's age, and we could have, if you want to find the average, we can just add up all the ages and divide by the number of people that we surveyed. But because we are taking only a few number of people from the entire population, and because of limitation of time and cost, in that case, the sampling, there would be some error that will creep into the entire estimation or this particular process. That is this sampling error. And every time we draw a sample of the same size, the values would also vary. So it is not exactly the same values will come again and again. So there is also variability over there. So as we can understand, the more number of people that we study, this will reduce. So sampling error can be reduced with appropriate sample size determination. So that means if we want to reduce the sampling error, we have to increase the size of the population. And sampling bias is caused due to inappropriate selection of sampling technique, sampling frame, etc. Sampling technique means what is the method of collecting the samples, as sampling frame is is in what way we are doing the sampling. Means, for example, somebody is conducting the telephonic interviews to collect samples. So that is the sampling frame. So sampling bias is basically if we have done something wrong with the way we have collected the sample. So it is not related with the size of the sample. So if we have designed the survey procedures wrong, then there is a sampling bias. So sampling error creates impact on the variability of the estimated parameters average, whereas sampling bias directly impacts on the value of the average. So that means if there is sampling bias, we end up with a parameter estimated like an mean of a particular of a sample. In that case, the mean actually is would be wrong if there is sampling bias. That means if my survey design, all these things are wrong, then we end up with a value for this particular sample, which is actually it's very different from the actual population mean. But if there is sampling error, that means if the sample size is wrong, then what happens? The variability of the estimated parameters vary. That means every time I draw a sample, the deviation from the mean would be higher. So if I take an average of all these draws for the mean value, then automatically it will show the mean overall, it will be near to the population mean, but the variability would be high. The standard error or the standard deviation of this observation should be high. So sampling error is related with precision, and we can say precision means how close are repeated observations near to the observed values. That means these are the observed values, these blue ones, sample values. How closely they are set, that is basically precision. So this is very, very precise. But this one is not, because we are taking from different, as you can see, these are all spread over. Whereas sampling error is related with the precision of the sample survey, whereas sampling bias is related with accuracy of sample survey. So when sampling bias is there, then the estimates are not accurate. For example, in this case, you can see even though the readings are precise, the estimate is wrong, because I may be studying a totally different group of people, or we are designed the survey in such a way so that this is studying only a certain type of people in the entire population and not the not all the different kinds of people. That is why it is not an accurate result. So there is a sampling bias over here. And when we talk about precision and imprecision, here we can say that this is both inaccurate as well as imprecise. That means neither it is precise and neither it is inaccurate. So we can say that because sampling error, if we increase the sample size, we will have more number of samples, and then probably the precision will improve. So sampling bias, as we were discussing in the last slide, sampling bias results from enumerator or surveyor focus. That means depending on the surveyor, whom he is surveying, and if he is focusing on certain groups or he is taking a judgment in the field where he is he's only looking into well-off individuals, so he is missing the poor people. So that leads to some amount of bias from the enumerator's point of view. So that is this is the first problem that results in sampling bias. And then depending on the sampling frame, there is also bias. For example, when we are doing a telephonic interview for car ownership, automatically we can understand presence of telephone and presence of car are correlated. So the sampling frame and the properties of the subjects are correlated. So there may be error. So we would only get well-off individuals. Then if it is a random survey, and we are using random tables when we will explain random tables in the next slide. So what it means is, if we decide on a list of people whom we are going to survey, which is randomly selected of course, then when during the survey we will find that that particular household is not responding, is not willing to respond, or they are out on a vacation. So that also leads to some problems. So if you have a pre-decided list of people to survey, then we may not end up getting all of them in the list. Then depending on how we are paying the surveyors or the enumerators, it also leads to certain problems. For example, when the payment is on a completed form basis, the surveyors will rush to complete the form. So that means they may not fill all the points in the form, and they may ignore certain parts of the form that needs to be filled. So they may say later on that information was not available. Or payment, if the payment is alternatively, if we pay by hourly basis, then the productivity also may suffer. So these are the different issues with the payment part. And then there is human error. That means sometimes, because maybe for the payment basis, like it was based on form, people may just not do the actual survey but fill the survey with bogus data, which may lead to problems. So this is this is of course human error. And then some misrepresentation on responders' response, particularly for qualitative surveys and all. When we are having a discussion and all, the surveyor may misinterpret what the person who is serving is actually trying to say. So that there may be some errors from that. And then there could be very high rate of non-response, and this usually happens when there is pick up and drop off survey or online survey. That means we may send the survey form to many people, but they may not respond back. So these are the different forms of sampling bias that can occur. So how do we remove sample bias? First of all, through sample design. That means we design it in such a way so that there is no chance of the surveyor to modify it in the field. So that means they have to take in the inputs that they are supposed to. They cannot leave certain things blank, or they cannot fill it as per their own wish, and so on. And then we need to check the accuracy of the data. So how do we do that? either we can verify the data with a secondary source, or if secondary source is not available, then for part of the survey we can resurvey via phone or directly, and then we can find out if the responses are same. So that is also we can do, and we can also try to increase the effort or increase the response rate by either giving multiple reminders or by paying money for filling up the forms. So these are the different ways we can address sample bias. And along with sample bias, sampling error also we have also discussed, and it depends on if we have optimum sample size is estimated to reduce the sampling error, and considering both time and cost of survey, we may come out with a size of sample or the number of samples that we will collect, and that will be taken up in the next lecture. So now talking about the different sampling procedures, there are broadly two broad categories. We can say one is probability sampling and non-probability sampling. This is the first this is the first way of categorization, and the next one is restricted sampling and unrestricted sampling. Now probability sampling, as you can understand from the term, we are when every member has got same chance to be drawn into a sample from a particular population, then it is probability sampling. That means everybody has an equal chance to get selected in the sample. But when we talk about restricted sampling and unrestricted sampling, this is basically when there are certain rules or certain restrictions that are first put in, and then we conduct the survey. That means we need to consider certain kinds of rules before we conduct the survey. So, and that's why we call it restricted sampling. So it could be, again, if there are no rules or such, then it is unrestricted. If it is having certain rules and all, then it is restricted. So looking at this particular table, we can see under probability sampling, there are different kinds of probability sampling, like simple random sampling, cluster sampling, systematic sampling, stratified sampling, and so on. Whereas in non-probability sampling, there is convenience sampling, convenient sampling, judgment sampling, quota sampling, and snowball sampling. So these are the different types of probability and non-probability sampling. And similarly, if I see this yellow color and gray color, so this yellow one, simple random sampling, convenient sampling, snowball sampling, there is not much restriction. Whereas cluster sampling, systemic sampling, stratified sampling, there are certain rules that we have to follow, or it is to some extent restricted. So these are again marked in gray color. So when we talk about probability sampling, we can say that every element of the population has equal and independent chance of getting selected as a sample, and it is either called random sampling or chance sampling. So this random sampling or chance sampling actually is the most common form of sampling that people undertake. But of course, there are different types of probability sampling. We will go into each one of them in details. For example, simple random sampling, there again the samples are collected from the entire population randomly. So it has got certain advantages. As you can understand, each element has equal and independent chance of being included in the sample, and so the chance of sampling bias and sampling error is less. It's a simple survey. Whereas the disadvantages are it requires a much larger sample size, so it is also costly. And not only that, the main problem is the full list of population is required before we start the sampling. That means we require the entire list of population or the list of people to select or give equal chance to each person to get selected in the sample. So if that information is not there, then we cannot do simple random sampling. Then this selection of sample in simple random sampling could also be done with replacement and without replacement. That means with replacement means I draw a sample from the population and then again I put it back into the population. That means I can again I have a chance that particular person has got same chance to be drawn again in the next draw. So that is with replacement. And without replacement means whenever we are drawing one person, we keep them aside, and in the next draw, this person is not getting again another chance to be getting drawn in the sample. So that is without replacement. Now in transportation planning, most of the random sampling is done without replacement. This is done so that we can improve the heterogeneity or the diversity of the population. So to give you an example of how random sampling is done, we can use random number tables. These are prepared by Rand Corporation, and this one is prepared by Rand Corporation. We can also use random number generators in the computer as well. Like in Excel, we can generate random numbers, even though we cannot give the seed or the initiation point of the random number in Excel. But we can have computer random programs which are random number generators. And either or we can use this kind of a table which we can carry in the field, and there also we can decide whom to survey. For example, suppose we need to survey 6 samples from 200 households. So we know this household numbers 1 to 200 beforehand. That means we know exactly which one is household 1, which one is household 2 till 200 households. We know which household is. We know this information beforehand, and then we first go to the random number table. We can select any row, any column. Let us start over here. This is second row and third column, and then we can say that because we have got only 200%, out of that we need to draw only 6 samples. So and in this random number table, all the numbers are of 5 digits, like 72300. So instead of taking 5 digits, we take the first 3 digits like 723, and then we can take this as the first selection from the random number table. But because this is more than 200, we will not take it, and we move on to the next one. The next one is also more than 200, that is 380, then 472, then 162. Now 162 is less than 200. So we take 162 and we put it as the first sample. Then we move on, and then we find that then there is 216, 355, and then there is 187, and we select 187 as the next sample. Now I have gone vertically down, but we can also go horizontally as well. That means depending on my starting point, I can go in any direction I want to find the next random number. Once I exhaust the line, I can again move on to the next line. So in this way, we can have 6 samples. As you can see over here, we can get 162, 187, 161, 159, 30, and 5. So these are the households where I will go and conduct my survey. And because all my household numbers are known, or this could be address numbers, so we can go to each one of these households. But again, the problem is, if one of those households is not there on that particular day, then we have to have another number which could be drawn in the same way, and we can add that after this particular, the last sample that is drawn. So the next procedure is stratified random sampling. As we have discussed, this is a restricted sampling procedure, and it is restricted because we are stratifying the population, or we can even stratify the sample as well. So the first type is, there are 2 types of stratified random sampling. The first type is simple random sample from a stratified population, and the next one is stratified random sample from a stratified population. I will come into, I will discuss this after a little bit in details later on. And we can say that in stratified random sampling, elements within each stratum are homogeneous in nature, and between strata heterogeneous. So that means within each strata, items are homogeneous, and between strata, these are heterogeneous. That means we are dividing the entire population into different groups having different characteristics, and we are doing survey of each group so that we make sure that all groups are represented in the sample. So either we can say that if I have to collect the same example like 6 households, and there are 2 groups, then I will take 3 from each of these groups, because there are 2 groups. So a simple random sample from a stratified population means I stratify the population into certain number of groups, maybe in example we can say 2 groups, and then we have samples, same sample size for each strata, and we have to collect that number of samples from each strata. For example, from the first strata we have 3, and the next strata we have also got 3. But in case there is lot of people representing that one strata out of these 2 groups, then we may end up with having more number of samples from one group, whereas the other group we are only having the same number of samples, but because there is lot of people in that group, we may end up with certain sampling errors. So stratified random sample from a stratified population actually takes care of that by taking the same sample fraction as per the number of people in each of this stratum, or the population in each of this stratum. So sampling fraction instead of collecting same sample size from each stratum. So that is how we again subdivide it. And then in the advantages of this are sample size in each stratum can be controlled for highly skewed data, and the disadvantages are detailed information of the population is required, which is same as any random sampling. Stratification is challenging in case of classification considering multiple characteristics. So if we stratify based on income, it is not a problem, but if we have to stratify based on income as well as education and other characteristics, then how to stratify becomes problem, and we end up with lots and lots of strata. So in multi-stage sampling, this is again over here no prior information is required, but and again this is applicable in case when the data collection requirement is at a very high level, maybe at a city level or at a national level data collection process is going on. There it is very difficult to survey a sample from the entire population, and if there is the sample size is huge. So what we do is, for example, when we do national level travel diary survey, that means we are taking into consideration what kind of travel choices or trips people make or households make in an urban area. For entire India, we don't need to start the sample design from India itself. What we do is we divide the population at the state level and consider each state as total population for the next step, and then we divide the states into district and select only a few sample districts. We don't need to select all the districts, and within each district we can identify the urban areas, and again we don't need to take into account all the urban areas. We can take some sampled urban areas, and then within each of those sampled areas we can determine the travel TAZs, the travel analysis zones, and then we enumerate each households within each TAZ. And there that is how, and we can of course select sample households from TAZs based on simple random sampling technique. So that means we are not bothered about the randomness of the sample at the country level. We can break the sample into different stages, the sampling procedure. We can first select states. From states we can select districts, and we can take only a few sample districts. Then within each districts we can again break it into different urban areas. Then we can take only sample urban areas, and within that we can do normal random sampling. We can adopt random sampling techniques, and that will actually reduce my time, and it will also we don't need to assign unique ID to the entire population. We can reduce it to the TAZ level. And different sampling techniques could be also adopted in each of the different stages. That gives you also flexibility. And of course, as you can understand, because we are breaking it up in so many stages, accuracy suffers to some extent. So then we have cluster sampling, which is similar to some other sampling procedures, but the only difference is the total population is divided into several groups or cluster. And this could be based on geographical area, where we call it area sampling, or it could be based on other criteria as well. And then these clusters are selected randomly. That means we first break the entire population into clusters, then we select some of these clusters for detailed study randomly. We don't study all the clusters. Now that also means that the clusters should be, the population within the cluster is heterogeneous. That means there is variation. We can see the heterogeneity of the entire population within that cluster itself, but the cluster itself is homogeneous. That means the different clusters are homogeneous. That's why we can select only a few clusters for studying in detail. All the elements within the selected clusters are then treated as selected samples, and then we can determine the different parameters based on this particular sample. Or this is a single stage clustering. If we go for two stage clustering, then cluster sampling, in that case a random sampling technique could be also applied on the elements of each cluster to determine the final sample. So both a single stage and two stage clustering could be taken up. So advantages, again, cost is lower than simple random sampling. Disadvantages, high sampling error, which increases with similarity within the cluster. Then comes the systematic sampling. This is the most common sampling adopted in when we do different land use transportation studies or transportation studies in general. Here every ith element after the randomly selected starting point is selected as sample. That means if I am serving households, I may select houses in an urban area. I may randomly select the first house, and after that we can take every ith house, or it could be every 10th house or every 20th house, depending on my sample size. So if I have got 1000 households and if my sample size is 100, so I will take every 10th house. So advantage is it's easy to design by any kind of surveyor, and of course it is less expensive because the sampling and it is not that difficult to conduct. And disadvantages are it is not exactly as random as simple random sampling, but still there is a lot of randomness which could be adopted for standard planning studies. So then coming to non-probability sampling, these surveys are mostly useful for qualitative studies and exploratory studies like a pilot survey. That means before we even go for actual survey, we may conduct a pilot survey to find out about the characteristics of the population. We want to explore what this the problem in question or the objective of a study in question. We need to have a broad understanding of the population so that we can actually design our sampling procedure. So this is a pre-step step process to the actual sampling that has to be done. But again, there are other studies which are qualitative, where we don't need to do detailed random sampling. We can discuss with people and we can find what they think, and we can choose certain number of people or certain types of people whom we require for this kind of discussions. So that is why these are non-probability techniques which could be also adopted in the survey process. So of course this requires very little time and cost, because we are not again creating determining the total list of population, then randomly selecting from that. We can just go and start our survey at our target location. And disadvantages, this of course, because we are not doing proper we are not randomly selecting the population, sample population, it may result in a lot of bias. So the first type of non-probability sampling is convenience sampling, where only available responders are surveyed. And so for example, we go to if we want to find out who are the people who use both paratransit and bus. So we go to the locations where paratransit stop and bus routes are there, and we randomly survey people, because if we have gone to the household, we would have end up serving many people who don't even use paratransit, neither they use bus, or they may use bus or they may use paratransit, they don't use both of them. So that is how random people, whoever is available and or willing to respond, are surveyed, probably in a market area, or it could be a park, or it could be a bus stop. And these advantages are simple and fast procedure which saves money, time and effort, whereas disadvantages are credibility and rationality associated with this method is of course lower than random samples. So consecutive sampling is almost similar to the this convenience sampling, but here available responders or groups of responders from the population that is surveyed are studied over a period of time before we move on to the next group of samples. So that means we complete our study over here, determine certain characteristics and all, and certain modifications could be adopted in the next group of survey as well, based on the studies that we do on the first group of samples. So this is consecutive sampling. Then there is quota sampling, where we can actually divide the population into different groups or quota and then interview and obtain response for each of these strata and quota. And sampling is done on the field, and extra care is required to make the survey random. So again, we try to make it as random as possible, but sometimes it is because we may design it on the field, it may not be possible to make it as good as stratified random sampling maybe. So we may have preferential bias in parameter estimation. That means the enumerator may prefer to choose certain groups or certain survey certain households, type of households, and ignore other kinds of households. So this kind of bias may creep in, and certain parameters are overrepresented and others are not, since surveyors select easily available responders. So these are the problems with quota sampling. Then there is judgmental or purposive sampling, where responders are selected based on the researcher's preconceived notion whom they found suitable and useful. And as you can understand, that means the surveyor decides whom to survey, and that is valid when, for example, there is requirement for an expert opinion survey. So the survey should determine who are experts in the particular field and then go and conduct the survey. And finally, we have snowball sampling, where enumerators first approach available responder who is suitable for the particular study, and then once the survey is completed, the responder is then asked for contacts of other potential responders. Now this may seem odd, but actually this is very useful when the target group is very difficult to find. For example, people suffering from a particular disease, I may get the first few people, and then we can ask the others for if they know some other people from their doctors, from doctor's appointment and all, with people suffering in similar kinds of diseases. So we can get to know from them as well, from support groups and all, for those peoples. So these are the different kinds of sampling procedures, and we have covered both probability and non-probability sampling. These are some of the references you can follow. So we can conclude by saying that sample design should be both comprehensive and efficient. While sampling error can be reduced through appropriate sample size determination, sampling bias can only be reduced through careful survey design and execution. The selection of sampling procedure should be as per the context and the requirement of the study. Random sampling or stratified random sampling is only possible when full population list is available. Transportation researchers often fall back on systematic sampling to conduct household surveys, which is easy to execute on the field. Thank you.